In the Babylonian math, because they use this sexagesimal notation, which makes much easier calculation. And even they have, even it looks like very complicated, they have these 60 different symbols for that base system, right? So this is a good kind of comparison between how easy of calculation if you use positional number system, right? But remember, Babylonian didn't use that zero, right? The symbol. So later they have some kind of style, but they didn't usually have it, right? So it's kind of pseudo positional system, but it's a big difference compared to the other ancient number system, right? And it makes much easier calculation for everything. But still, they didn't have like what he had, right? So it's a little bit requires calculation for that. So their method, for example, the other parts are kind of easy enough, like addition, subtraction, multiplication. It's kind of doable. The other problem came from the division, most likely, right? So when they need to get the division, their method is instead of division, developing other method for division, they treat that as multiplication by the reciprocal of a divisor. That's what we usually do, right? Okay, that's the main concept. So, for example, if they want to calculate 7 divided by 2, they actually think like 7 multiplied by 1 half. Now, how can you handle that 1 half? That's the question. In our number system, be careful. That's the kind of real confusing thing. For the explanation and get the concept of them, we use our own number system here, right? So they didn't use that way, so be careful for that part, right? So 1 half, what is the meaning of it, right? They didn't have 1 half. Once again, their base is 60, remember, right? So you have to think that way. So instead, the meaning is 1 half, but they don't have any the symbol like that. So they have to calculate certain things, right? To find the matching symbol for that. So let's assume this. 1 half need to convert to their system, which is base 60. 1 half is between 0 and 1. So that means that number can be written by 6 x over 60. Okay? Right? In our case, 1 half can be written by what? 5 tenths, because our base is 10. So same thing, right? What symbol or number should be good for that x, the numerator, with base 60? Then simple calculation, right? X equals 60 over 2, which is 30. And remember, they have the symbols from 1 to 59, right? So they have symbol for 30. This is not a problem for them. So they could figure out 1 half is equal to 30 of 60, right? And once again, this is between 0 and 1. So after semicolon, they just put the symbol for 30 there. And that is good for 1 half. Now, so far we only know, we cover what is their real notation for 1 half, right? We didn't calculate the entire one yet, right? So let's just calculate. Go back to original question. 7 divided by 2 is same as 7 times 1 half, like that. Then that is same as 7 times semicolon 30. We use our symbol for that, but they have symbols for 7 and symbols for 30, right? So in their formats, right? Then they need to calculate this 30 times 7 in their own way, but let's just skip that portion. Okay? So they should get to 10. Now the position of that is 1 after decimal, right? The first decimal position. Okay? So that's 30, and we got 70. So after we calculate it, we have 210 after decimal, right? But our basic system is 60, which means we have to calculate how many 60s into 10. So it's 3 of them, right? And remainder is again 30, right? So meaning is 210 is 3 times 60 plus 30, which means we need carry over 3 to the one left. So instead of this is not good way of writing. We have to move 3 to the one left and put down the remainder. So it's 3 semicolon 30. Of course, in this case, its base is 60, right? Can you imagine that? But if you convert that one to 10, then it's kind of, yeah, 3 is 3, but that should be like half, right? Okay, so that's what they did, and this is what we want to do in this chapter for practice purpose. Now, remember, in our number system, if we have 0.1, 2, 3, then the meaning is 1/10, 2 100ths, and 3 1,000ths, right? That's the meaning of it. And actually that is 10 and 10 squared and 10 cubed, right? So technically, if we have same 1 and 2 and 3, right, in their format, base 60, then the meaning for that is 1 60 and 2 60 squared and 3 60 cubed, right? So please keep that one in your mind. And let's look at this question. We want to divide 11 by 9 using that Babylonian method, right? And multiplying the first number and by the reciprocal of the second one, like that, division. So let's calculate 11 divided by 9, and in their method, it should be 11 times 1/9. And the first thing we have to check is to find out the corresponding notation for 1/9 in Babylonian numeric system. So we just put x over 60 for that. Then from there, x must be 60 over 9. And you can take the, so for those calculation part, we're using our own method, but Babylon did that actually with their own style, right? Or they have many tables and stuff, right? So they could use this cheating paper and to get the answers. But okay. So for just the explanation purpose, let's just calculate it. So the same as that. So eventually same as 6 plus 2/3. Okay. So from this result, we could put 1/9 equals 6 plus 2/3 over 60. Now look at here. That is same as 6 over 60 plus 2/3 over 60. Right? Then as you can see here, any number which is between 0 and 60, it can be placed here, right? But any number is less than 1, okay, over there, then it must be written in this format, right? In the next decimal position. So when you have some integer and some number which is less than 1, right? Of course, between 0 and 1, but like that, then this 6 can be the numerator of 60, but this one should convert to for 60 squared, right? For the base. And this is how to get it, right? So 6 over 60 is good enough, but we need to change this one, right? So that is 6 over 60 plus 2 over 60 and 1/3. But we want to get 60 squared for the base here, right? So let's just change this one to 60. So 6 over 60 plus 2 over 60 and make it 60 because we need 60 squared here. Then how much do we need? Multiply by 20 for numerator and denominator. So we need 20 over there, right? So altogether, that is 6 over 60 plus 40 over 60 squared. Then we can show this one in the Babylonian style. Okay? Semicolon, because there's no integer, and 6 must be the first place, and 40 must be the second place. Of course, using their own symbols, right, for 6 and 40. Okay? But let's just use our own symbols here. So all together, we are looking for actually, this is only for handling that portion. So the actual calculation is 11 divided by 9 is 11 times 1 9, which is 11 times semicolon 6 comma 40. So we need to multiply 11 for each of these numbers in each position, right? So the first one is easy, like 66, and 11 times 40 is 440. Now the problem is we cannot put any number greater than 59, right? Even if it's a 60, then we have to one carry over. Like in our traditional one, if you say, oh, come dot, right, 2.12 3, 4, 7, there is no 12. We cannot say that. If it's a 12, then we have to carry over 1 to the left side, right? Remaining only 2, and it becomes 3, right? So exactly the same thing happens here. So it's better to start from this portion. So 440. Okay, so let's just calculate one by one. Let me just make sure the position is second decimal, actually. Then that can be changed to how many 60s? 7 times 60s. Please calculate, and remainder is 20. Then that portion must be carried over to that place. So semicolon 7 comma 20, right? And the next one is for 66. So that is same as 1 times 60 plus 6, right? So one carry over to the left. So 1 semicolon 6. And we want add these two, right, to get it. This one, right? So semicolon 66 comma 440 must be 1 comma 1 semicolon and 13 comma 20, right? Okay, so this is how we calculate it, but we got the answer. So not this one. Okay, there's no such notation like you can put 12 or something like that, right? So it's just the meanings of it. So eventually the actual notation should be 1 semicolon 13 20, right? So that's the actual result for this one.